Hi and good morning everyone. My name is Alif Aiman. I'm the leader of Plato Group. Today my group will present about the overview of the topic of predict motion and flight mechanics. Predict motion is the motion repeated in equal interval of time. For example, bouncing ball and swing in motion. The formula is frequency equal 1 over t. T is the period. Next, oscillation is the repeated back and forth movement of something between two positions or states.
Okay, next we go to the simple harmonic motion SHM. As we know, we have learned this topic since we were at foundation and matriculation, so I just make an overview to this topic. First of all, simple harmonic motion is about the repetitive movement back and forth through an equilibrium or central position. Hence, the maximum displacement on one side of this position is equal to the maximum displacement on the other side. Next, we go to the equation of SHM. We can see the velocity as a function of time v equal to negative a omega sin omega t, and the acceleration equal to negative a omega squared cos omega t. Both of these are found by taking components of the circular motion quantities. Then we go to the energy of SHM. As we can see, there are many formulas in energy conservation in oscillatory motion. Last but not least, simple pendulum is an example for the application in SHM because a simple pendulum consists of mass suspended by a string or rod of length. That's all from me, thank you.
Okay, now I will explain about fluid mechanics. Fluid mechanics is a branch of applied mechanics concerned with the statics and dynamics of fluid. So when we talk about fluid is a substance that has no fixed shape and reacts easily to external pressure. Fluids may be divided into two, which is liquid and gases. And now I will go into one of the sub-element of the fluid mechanics, which is the density. So by definition, the density of a substance is its mass per unit volume, which we can see from we can see at the formula, which is rho over mass. Density is equal to mass over volume. And we also had relative density. Relative density is the ratio of the density of a substance to the density of a standard. So at the formula we can see that relative density is equal to density of a substance over density of a reference. So usually the density of reference, we use water for the reference of the density. Okay, that's all for me. Next we will go to pressure.
Hi everyone, my name is Saifa. I will continue this presentation. So pressure is defined to be the amount of force exerted per unit area over which the force is applied on an object in the fluid or on the surface of a closed container. Next is Pascal's law. Pascal's law states that any force applied to a confined fluid is transmitted uniformly in all directions throughout the fluid regardless of the shape of the container. The standard SI unit for pressure measurement is the Pascal, which is equivalent to 1 Newton per square meter. Next is buoyancy. Buoyancy is the force exerted on an object that is wholly or partly immersed in a fluid. Archimedes' principle, which states that the buoyancy force is equal to the weight of the displaced fluid. Bernoulli's principle. Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in static pressure or a decrease in the fluid's potential energy. So next is continuity equation. The continuity equation derives from a fairly obvious conservation law, which is conservation of mass. The rate at which fluid, which is air, flows into a region has to be the same as the rate at which it flows out. And the last one is viscosity. Viscosity is a measure of a fluid's resistance to flow. It describes the internal friction of a moving fluid. Imagine a styrofoam cup with a hole in the bottom. If I then pour honey into the cup, I will find that the cup drains very slowly. That is because honey's viscosity is larger compared to other liquids' viscosities. If I fill the same cup with water, for example, the cup will drain much more quickly.